Welcome in ADSUL'S Technical Campus, Faculty of Engineering and MBA, SAS Ahmednagar. Today, myself Professor Jyoti Thandge, presenting practical number 1 in power electronics. The name of the practical is VI characteristics of ESCR. Now see, this is the aim of our practical, VI characteristics of ESCR. Now, what will be the program outcomes we'll get when we study this practical? First program outcome is discipline knowledge, second one is experiment and practices, and third one is engineering tools. Now, what is discipline knowledge? First of all, in discipline knowledge, you will get the knowledge that how to apply the electrical engineering knowledge to solve the breadboard based electrical engineering related problems. It may be breadboard, it may be circuits, or it may be different kit also there. Now second one is experiment and practice. In this experiment and practice, it is nothing but the ability to plan and perform experiments and practice to use the result to solve engineering problems. And third one is engineering tools. In this you will get the knowledge to apply relevant electrical technology and tools with an understanding of the limitations. Now, next one is course outcomes. These course outcomes, you will get the outcomes that select the power electronic devices for a specific application by studying this experiment. Now, next one is practical outcomes. These practical outcomes, when we learn total practical, you will get the two practical outcomes. First one is latching current. You can determine from this practical, that is latching current and holding current. This latching current is nothing but minimum amount of current that latch the SCR in on state. And this holding current is nothing but the minimum amount of current that hold the SCR in on state. And after studying this practical, you can also draw the VI characteristics of SCR, that is voltage versus current characteristics. This voltage is nothing but anode to cathode voltage, and this current is nothing but the anode current flowing from anode to cathode. Now see, theory related to this practical. First of all, we know the SCR is a unidirectional device. Means current will flow in only one direction, that is from anode to cathode. Second point, important point is SCR having three terminals, that is anode, gate and cathode. These are the three terminals. Next one is, it is a 4-layer structure having alternate P and N layer are there. That is a P region and this is the N region. This is made up from P and N region, and also we can say that it is a combination of two transistors, that is the PNP transistor, and second one is the NPN transistor. Also, next important point is it has three junctions. You can observe here between P and N, first junction is present, junction J1. Between N and P, second junction is present, junction J2. And between P and N, third junction is present, junction J3. These are the three junctions. This is a normal theory or a common theory related to SCR. Before learning this practical, it must be known to all students. Now, this is the symbol. See, in this symbol, again there will be three terminals. First is A for anode, K for cathode and G for gate. This is the symbolic structure of SCR. Now see, next point, that is practical setup. Here VG, that is the gate voltage, is applied and it will vary from 0 to 30 volt. First of all, I will connect here resistor to protect the another circuits. After that, I will connect the ammeter having the range 0 to 10 milliampere. It may be vary from 0 to 30 milliampere also. Now, this supply is given to the gate terminal of the SCR. This is the SCR. And also this anode terminal is connected to the ammeter to measure the anode current. And also after that 1 kilo ohm resistor is there. After that 10 kilo ohm resistor is there having the different wattage. It has 2.5 watt and it has 10 wattage. Now parallelly I will connect the V to measure the anode to cathode voltage. It will exactly parallel to the SCR to measure voltage between anode to cathode. After that, here I will connect the another power source, another DC source, that is having the range 0 to 150 volt. It may be variable, hence shown by dotted line. Its value can be vary according to the we need, or we can say that according to the applied gate supply, it will be variable. Now this is the practical setup diagram for the VI characteristics of SCR. Now next point is resource required. Now which of the resource is required? First of all, we need regulated power supply, and this regulated power supply we need two regulated power supply. First will having the range 0 to 30 volt and second will having the range 0 to 150 volt. Having the range 0 to 30 volt used at gate used between gate to cathode, and 0 to 150 range this power regulated power supply used between anode to cathode of SCR. Now second one will be ammeters. Required resource will be ammeters. There will be we need two ammeters. First is having range 0 to 10 milliampere, or it may be 0 to 30 milliampere if not having 0 to 10. Then second ammeter will having the range 0 to 150 milliampere, which is connected at the anode side to measure the anode current, and 0 to 10 milliampere used at gate side to measure the gate current. Next one is voltmeter. This voltmeter is connected exactly parallel to the SCR and having the range 0 to 100 volt. Next one will be the SCR. Will be there having the values having the types TYN604 or TYN612 or any other SCR available in your laboratory. Next one is a register. Register are three registers are there. I will write here two only, but three register. First one will be at gate side having value 3.3K. Next one will be 1 kilo ohm having the wattage 2.5 watt, and third one is 10 kilo ohm having the wattage 10 watt. Now these are the register, or these are the resource required for the SCR practical setup. Now see the procedure. First of all, what is the procedure for characteristics? See, first of all, for drawing the characteristics, connect all the devices as per shown in circuit diagram. After that, switch on the power supply. When you switch on the power supply, apply the gate pulse to the SCR. After that, increase the anode to cathode voltage step by step, up to where your SCR goes in on condition. This will be the normal procedure. Now we have to take the different reading. For that purpose, first of all, open circuit this gate pulse, means gate pulse will be 0. When Ig is equal to 0, gate pulse will be 0, means Ig is equal to 0. 0 current flowing through this ammeter. At that time, increase this voltage between anode to cathode up to SCR get turned on. This value will be VAK when Ig is equal to 0, and also note down the Ig current. Also note down the IA current. After that, apply the gate pulse having the current, gate current 1 or 2 milliampere, and also apply this voltage, increase this voltage up to turn on the SCR, and note down this voltage as well as anode current reading. After that, again increase for third reading, again increase gate current up to 4 milliampere and so on. This procedure will be repeat up to 6 to 7 readings. Then you will get the value of VAK, you will get the value of IA, and you will get the value, different value of IG. Then you can easily draw the VI characteristics of SCR. And this VI characteristics of SCR is nothing but on x-axis there will be voltage between anode to cathode, and on y-axis there will be the current, that is anode current. When Ig is equal to 0, when your SCR goes on, this value is called as a VBO, that is breakover voltage. After that, increase the apply the gate pulse. Then your applied breakover voltage goes on decreasing. Means you will get this value. After that, this value. After that, this value, and so on. In this way, you will get the characteristics of SCR. This will be the graph after taking the readings. This value, at this value, Ig is equal to 0. After that, you can increase Ig1, Ig2 is greater than Ig1, Ig3 is greater than Ig2, and so on. This procedure you may repeat for 4 to 5 times or up to 6 times. Next one is for latching current. How we can calculate the latching current? To calculate latching current, first of all, Vg, make Vg is equal to 0. After that, then also your SCR is in on condition. Then reduce the VAK up to getting some value where it will be remains in on condition. Then you will get the latching current. Now again Vg is equal to 0 for calculating holding current. Vg becomes 0. Then also make this VAK is 0. Then increase it up to turn on the SCR. Then this current is the holding current. In this way you will get the characteristics, that is VI characteristics, then latching current and holding current of the SCR. Now what is the conclusion? Last point is conclusion. From this we can conclude that latching current is always higher than holding current. And second one is your anode to cathode voltage when reach to breakover voltage, then and then only SCR goes in on condition. Otherwise, below this breakover voltage, applied voltage is below this breakover voltage. In this case, your SCR is in off condition. This will be the conclusion of this practical. Thank you.